Hello again and welcome back. I'm John Ball, the inventor and developer of pattern brain theory. So as you can imagine with that introduction, I'm very interested in how we can exploit what the brain does for technology purposes. And today's biggest competitor is probably the large language model. Large language models have a fundamental limitation, which is their confabulation. What they do is they make stuff up. Some people call it hallucination, but hallucination would suggest that it's actually storing the knowledge that it's misrepresenting. But confabulation is just it's making stuff up, and that's the right term for this particular problem. So rather than talk about large language models and describe what they do, let's have a look at one. This one here is coming from the Brave browser. I think they call him Leo. And by looking for the 1956 Dartmouth conference where AI was founded, we get a little summary of what happened there, what the key outcomes were, what the research project was about. I mean, the participants are the who's who of AI in the past, such as John McCarthy from Dartmouth, Marvin Minsky, the robot guru and the guy giving expert advice to lots of AI companies at the time and movies. From MIT, Rochester, from IBM, and Claude Shannon, the guy behind the information age, the information guru, from Bell Labs. And have a look at that. That's interesting. We've got Alan Turing that was at that event as well. So all of the information I've just shown you has been generated by the LLM. It's taken its training run and it's generated this probable word sequence as a result. And it's confabulated. It's made some errors there because it just made stuff up. How can we test this? Well, if we go to Wikipedia, Wikipedia is curated by humans rather than this generative AI, and we can see some differences. So let's have a look. Here at the top is the Alan Turing entry from Wikipedia, and at the bottom here, there's something about machine learning. So his death was 1954, sadly. And here we've got in the summer of 1956 was when the Dartmouth conference took place. And in terms of common sense, I think we can both agree that if he died in 1954 and he's supposed to have gone to that conference in 1956, he was not at that conference. So that's a confabulation. At the Dartmouth conference, machine learning couldn't have been the topic of discussion as you and I understand it in 2025. What they meant by machine learning was this synonym here, self-teaching computers. So the idea was that a machine would teach itself. And that's a great idea. If you had a machine, and Turing talked about it, by the way, if you could train a machine to learn by itself, then it would use its vision and hearing and so forth in order to change the world, in order to become like us, as children do, and problem solve. Today, when they talk about machine learning, there's different forms of it using supervised, unsupervised, semi-supervised. There's people that are involved in validating data in order for it not to create lots of problems in the system that they're creating. So it's important to recognize that there's this temporal dimension, that things that happen today, a name that we have today, you shouldn't inject into a 1956 article because it's not correct. That machine learning that we're picking up on is not a synonym for the types of machine learning they were talking about. So let me just summarize. Patom theory is about emulating the brain and doing what I just showed correctly. You want that information panel to be generated by a human emulation capability that is accurate as a person would be able to do it if they were to read the source material and come out with that answer. Machine learning and the large language models are using a statistical model of a knowledge base. And because the statistical model doesn't have direct entries like a knowledge base itself would, what it does is it confabulates. It makes up an answer that's the best answer it's got based on its statistical representation. I'm still not sure how it could have come up with the fact that Alan Turing was at a conference after he died. Large language models have a statistical model of a knowledge base, but a large language model could have a real knowledge base that is lossless and human-like. That's the type of technology that I work on. So what I've talked about is that as a symbolic architecture, which is pattern brain theory, and a statistical one, the statistical one where the knowledge base is statistical in nature, it has to confabulate when it doesn't have an accurate representation of knowledge. If you had an accurate representation of knowledge, as we have in pattern theory, you should be able to then answer questions without ever producing an error. But the fundamental difference is you have to have, rather than word vectors that are these statistical models, you need to have human-like representations, as we would understand from sematicists, one of the branches of linguistics. So that's probably it for today. Thank you for joining me. I'm glad I had a chance to take you through what the large language models are doing and what the limitations are. And there'll be more coming up as we get into 2025. Thanks for joining me again today, and bye for now.